Hi everyone, Pratik here again from Beehives, and I warmly welcome you all again. So this is the part 2. Without wasting any single minute, we will directly jump onto the topic. So in the first part A, we have already seen these steps. So now from here onwards, we need to have a simple cutout and a weld flange. So let's get started. So even in this area, you can even go with the profile sketch, what I have already discussed about. If you're good enough in constraining, then go ahead with the profile or simply draw a rectangle. That's what I'm gonna do now. So the very first thing, I'll delete the blend, say OK, and then go with the rectangle. So let's start with the sketch and simply take the rectangle point here and draw that. I'm gonna hide the component because I have took the point reference from the model, so I'll delete that constraint, coincident constraint. Okay, so now I have to give a dimension at the start point, take it from the axis, vertical axis, this dimension, have an angle 6 degrees, it seems to be okay. Then give dimension, we'll go with the larger one, and here again length 50. That's it. Even you can increase this length, it doesn't much matter because anyhow it's gonna be trimmed. So we have fully constrained sketch, just finish it, check out the model. Okay, just delete the blend. Again, we have a similar cutout at this area, so instead of drawing a new sketch, you can go ahead with the same area section into the same sketch. Always use edit with rollback so you can go into the proper sketching environment. Just point to remember, guys. You can simply draw a rectangle or circle here. If you know the dimension before, then it becomes more easy. Geometrical properties, say it's 15 mm, it's a radius, so it's R15. I'm sorry, that's 30. So I'm gonna give dimensions. I'll avoid the coincident point again and give the dimensions. It was dependent on the model, so that's what we don't need it. Yes, so now we have this 2 dimensions and the sketch is fully constrained. Go ahead with that. So extrude both of the sketches. You can extrude or single at the one time, but I'm preferring both. I'll be using symmetric value again, just a bit larger than what flange we have. Say okay. Now we are left with the weld flange, and even there's an angle here. So give a draft, give an edge. So I'm going with, let's say 8, or it seemed to have more than that. You can measure the angle. Always you can go ahead with angle measurement. Say object first, axis, and part. It seems to have 170 and it's 10 degrees. So I'm gonna give the draft 10 degrees and say okay. Now there's a blend. I'll simply measure the blend, what exactly the value is. It's radius 10. That's it. So say okay and I'll apply the blend. So these are the things. So we have two extrudes and draft, fillet as given, it's completely matching at the end. Now we want to go with the welding flange. So this welding flange can be done with even a line, or we do not need any rectangle for that. Always remember to give a proper feature groups so that parametric model seems to be editable and it should be foolproof. I'm going again with the receive curve project. I'll simply use a project curve this time and say non-associative. Draw simple lines, extend it. Okay, what I'm gonna do is I'm gonna draw a line so that I'll get a constant dimension. That's a 30, and I'll delete this. I'm gonna draw a line. I'll move here, give a dimension here to here again, and I'll just simply trim off this curve, and I do not need this anymore, so that the dimensions from this point is constant. That's only one reason, nothing else. One of the dimensions will always be in a decimal, so you do not need to worry about it. I'm gonna give now angle. This seems to be 22 degree because it was already matching. So I'm gonna go with the line again and extend it to that point. Simply trim off or delete or give a dimension to the length. Let's say 40. That's it. So we have a line fully constrained. Just finish it. Go with an extrude command. Go with the vector. Always define a vector. I'm going with the symmetric value. Check the dimensions exactly, and go with the offset two-sided. One side it should be 0 and the other side it can be any dimensions more than the thickness. Always do prefer the dimension should be more than the thickness of the part. So I'm going with the 10 mm. Let's say okay. Now you have this, you have the basic geometry again. Now simply what you can do is unite it. The first, second, say okay, check for the blends value. Again, analysis, geometric properties, it's 2 mm, both the side it should be same. Okay, that's it. So I'm gonna hide it again. I'll apply the blend. It seems to be 2 mm here. Say okay. Now simply subtract the component. Use subtract command from this body. I'll remove this and say okay. Now you have a complete solid entity here. You can go ahead with the blends so that shell becomes easy to operate, or even you can go first with the blends what we need. 3, yep. So this is the 3 where we need the dimensions or blends. Again check here, 5, 6 seems to be okay, both the sides. So apply, eliminate here again, go with it, 1, 2, yep, and chamfer will give it afterwards, or you can either you can give in this stage also, it doesn't much matter. Check the dimensions, it seems to be 10 mm. Now this is what we have. Now you can go ahead and apply the blends all over, so that while applying shell command it will simply roll off the tangency surface what we need. I'm going with this. I'll simply click on this also because we need to take off this face as well. So this is how your solid model is created, and then finally apply the shell command. Shell, use the thickness, what exactly it is. Give a single face, use tangent faces, and this is how each and every face will get removed. When you applied the blends, it was all in tangency, so it gets removed. Say OK. Now this is how you can match the component. Now we are left with the hole, so you can simply extrude it again, the whole geometry. Always remove the hole afterwards or after the shell, because if you do it earlier you will have to edit the shell on multiple faces, and this is what I don't prefer. So this is the good thing, to subtract the hole at the ends. Many mounting holes or material removing holes or depressions you want to create, you can do it at the end after shell. It's completely fine. So this is the thing, and the remaster model is completed. Hope so you like it. Always check if your model is parametric or no, just by double clicking the coordinate system. Just move it a little bit, rotate it a little bit, and say OK. Your model should stay alive. Means alive, I mean to say the dimensions should not change, or you should not get any error. If you are getting any error when you rotate the axis system or move the component away from the basic point, the dimension should be always maintained, and that's what parametric model means. Okay, so this is all about remastering, guys. Hope so you like it. There are so many strategies or different components we do have. We need different approach to each and every model. So if you want to learn more, do reach us. If you have any questions, please comment below. Thank you so much. Take care and bye bye.